Hey guys, it's Mrs. Ronka. There are going to be a couple classes today that I'm not able to be at. Plus we have some students that are out, and I just wanted to go through these notes on here so you could look back if you needed any help. So first of all, let's just go over what we did yesterday. Like terms are terms that contain the same variable or actually no variables at all. And if they have variables, they'll have the same exponents or powers. So some examples of like terms would be, like a lot of you said in class, 2x and 3x, maybe 5y and negative 6y, or something like that. We could also have constants, which are numbers that don't have any variables. So like negative 8.3 and 7. It can be a decimal. And also if they have multiple letters, they have to have the same multiple letters. So maybe 2xy and negative 5xy. And then talking about having the same powers, this doesn't actually happen that often in geometry. It's more something you would need for algebra. But like 3x squared and 7x squared. Those would be examples of like terms. Now the main thing, I didn't go over this with all of the classes yesterday. The main thing with like terms is that you can add like terms, subtract like terms, multiply like terms, and divide like terms. So you can do all four major operations with like terms. With not like terms, you cannot add them and you could not subtract them. However, if they are not like terms, you can still multiply and divide them. So we can still multiply, we can still divide. So some examples of unlike terms, not like terms, or unlike terms, sometimes they're referred to, would be like 5 and 2x. You would not be allowed to add 5 plus 2x. You would not be allowed to do 5 minus 2x. You would be allowed to do 5 times 2x or 5 divided by 2x. So some other examples would be like 3a and 7b, so if the letters are different, or 2x squared and 7x to the third, or something like that. Okay, so if we're simplifying expressions, here are the examples for simplifying. Let me see if I need to zoom in at all. All right, so for simplifying, I like to circle the like terms and also circle the sign that's in front of them. So we have 7x minus 10x. So 7 minus 10 is gonna give me negative 3x. I've got negative 3y and positive 8y. So negative 3 plus 8 is going to give me positive 5y. And then I've got negative 5 and negative 8, and that's going to give me negative 13. So my final answer would be negative 3x plus 5y minus 13. If you're having trouble with negatives and positives, I either like to think about it as money, like I have $7 and I owe somebody $10. So to break even, I give them my $7, but I still owe them $3. So that's one way to think about it if you kind of want to do it mentally. You can also visualize a number line. And on a number line, when we add, we go to the right. And when we subtract, we go to the left. So if I was on a number line and I was starting at 7 and I was going to subtract 10, I would be going 10 units to the left. So it would take 7 units to get to 0, and then I would still have 3 more to go. So I would end up at negative 3. Same thing if you did negative 5 minus 8. So let me put the 0 down here. So if I was already at -5 and I had to subtract 8, I'm going left 8 more. So if I'm at -5, it's going to be -6, -7, -8, -9, -10, -11, -12, -13. So that's just a little review of positive and negatives. But ask me more questions about that in class if you need me to review that more. Okay, so in this one we've got -2x and -3x. So that's going to give us -5x. This positive 9y and negative 9y are opposites of each other. So they're actually just going to zero out. Positive 9 minus 9 is just 0. And then we're just left with -6. So -5x minus 6. This next one here, they have a lot of variables by themselves. I personally like to put a little number 1 in front of each variable by itself so I don't forget that it's actually a number 1 there. So I've got 7x minus 1x. So 7 minus 1 is going to give me 6x. I've got -1y and -1y. So if I do -1y minus 1y, it's kind of like you owe someone $1 and then you owe them another $1. So in total, you actually owe them $2. Or you could think about it on a number line. If here's 0 and you're at -1, you got to go 1 to the left. So you'd be at -2. And then again, we've got some opposites, -1z and +1z. So those are going to cancel to 0. So it'll be 6x minus 2y. And then this last one has 4xy, which matches with 7xy. So that's just 4 plus 7, which is 11. And then we have an xz and a yz, and so neither of these are like terms. So they're just going to come along for the ride to the answer because they have nothing to be combined with. So that'll be 11xy minus 4xz minus 11yz. This says to determine whether the equation below is true or false, and then tell how the two sides of the equation differ. So we can see here they're doing something called the distributive property. So this is actually doing 4 times 3 and 4 times +2. It is important when you do the distributive property, you include that sign in front. So 4 times +3 is 12, and 4 times +2 is +8. If it's a positive in the front, you don't usually need to write it because the first number, if it doesn't have a plus sign in front of it, it's assumed to be positive. If it has a negative sign, it's assumed to be negative, but you do need to put that plus sign in the second spot. Here, they wrote it out with multiplication dots, and it would be 12 plus 8. So we can see here that both sides of the equation are the same, so that is a true equation. It's only a true equation whenever both sides are equal. And the difference is that the left is distributive property. And then the right is multiplication dots. We use dots instead of X's for multiplication because once you get into algebra, sometimes you might consider, like, you can't tell the difference between a multiplication X or whether it's like an X for the variable. All right, here we're just using simplification, and we're remembering Pemdas. So hopefully you guys remember Pemdas. That was parentheses, but also you could think about it as grouping symbols. Sometimes they say that instead. So I guess that would be GEMDAS. Oh, I like that. I like GEMDAS. That sounds cool. And then the E is for exponents. The M is for multiplication. The D is for division. Now these two, they actually don't necessarily, they happen in whatever order they come from right to left, or sorry, from left to right. So they're not saying that you always do multiplication and division, like multiplication always has to go before division. With multiplication and division, it's whatever you encounter on your equation when you're reading it or your expression, from left to right. Same thing for the A and the S. So the A is addition, and the S is subtraction. So that's also from left to right as you encounter it in the expression that you're simplifying. So it's almost like there's really only 4 because these two are grouped and these two are grouped. So right here, I can see that we have some distributive property. So that's going to be inside the parentheses. So if we start with parentheses, inside here, x plus 4, we can't add those together because those are unlike terms. The E, we can see no exponents in the problem. So if we were really going through our list of Pemdas, we don't have any parentheses that we can simplify. Like this isn't like 2x and 4x or something. So we don't have parentheses to worry about. We don't have any exponents to worry about, so we can go ahead and do our distributive property. When we multiply a whole number by a variable, we just stick them next to each other, like that. And then obviously 3 times positive 4 is positive 12. And then we're just gonna bring this stuff down, negative 4x plus 2. And now we can combine our like terms. So we've got 3x and negative 4x, which is negative 1x. And then we have positive 12 and positive 2. So when we add those together, we get positive 14. So negative 1x plus 14. Or if you don't want to write negative 1x, you can actually write negative x. The 1, whenever it's in front of a variable, can be optional. So we can not put the 1 and just put the negative symbol, and that represents the same thing. On to the back. Oh, sorry, my pen kind of bled through there. So this type of distributive property right here, you want to be careful that you definitely use the negative 2 as you distribute into each of these terms. So we can't combine the x and the negative 3 because they are unlike terms, but we can multiply the negative 2 times x. So we're going to put, so I can just bring the 5 down. So that would give me negative 2x. And then be careful with this one because this is negative 2 times negative 3. And remember with multiplication, a negative times a negative is actually going to be a positive. So when you're doing multiplication and division, that's when I want you to remember the rule. A negative times a negative is a positive. A positive times a positive is obviously a positive. So negative times negative is positive. Positive times positive is positive. And then a negative times a positive is negative. And don't confuse those with addition and subtraction. That's talking about when you're multiplying. And then we can combine like terms. We've got a 5 and a plus 6. So whenever we write things, we like to write the terms that have variables in them first. So the negative 2x is just going to go first. And then I have a positive 5 plus 6, which is just going to be plus 11. For the next one, it's always easier whenever you're doing distributive property and the symbol in front of the number is a positive. Because then, sorry, I have dogs. They're nice. They just see either a person or some deer outside. Shh, hey, Mama, I'm doing math. Okay, the dog that barks the most, her name is Mama. And maybe I'll show them to you at the end of the video. Okay, so here we have a positive 3 times 2a. So, sorry, I'll just bring that down. So that's going to be positive 6a. And then positive 3 times negative 1. Remember, now we have a positive times a negative. So that's going to be negative 3. Here, if I do 6a plus 6a, that's going to be 12a. And then I can just bring down the minus 3. All right. Next one is going to be this doozy right here. So we're going to start with distributive property because none of these terms inside are like terms. So 2 times 7x is 14x. and 2 times positive 5 is positive 10. Now I don't bring this negative sign down just yet. What I want to do is multiply it by the x. It's actually like a -1 if you want to think about it like that. So I'm going to do -1x, and then -1 times positive 4 is -4. Same thing here, I'm not going to bring this negative sign down. I'm going to attach it to the 2, and I'm going to multiply it by 2x. So -2 times positive 2x is -4x. And then -2 times -1 is positive 2. And now I can go through and do like terms. 14x, -1x, and -4x. So I have 14 minus 1, that takes me down to 13. And then minus 4, that takes me down to 9. So that's 9x. And then here I have 10 minus 4, which is 6, plus 2, which is 8, and it's a positive 8. So that's why we would do 9x plus 8. All right, and then here we have solving equations, something I don't know if your teachers go through with you in Algebra 1, but when you solve equations, you're actually doing reverse Pemdas, so you're doing SAD-MEP. You actually want to check if you need to move anything with subtraction or addition first, then multiplication and division second, and then you take care of your exponents third, and your parentheses fourth. So you're working backwards. So here I see that it's x plus 12 equals 7. You want to get any of the terms that are like terms on the same side of the equal sign. So since this 12 is a constant and this 7 is a constant, those are like terms, I want them both to be on the same side of the equation. I've actually seen some students that move everything to one side and make it 0 on the other. I think it depends on what country you learned how to do math in, or maybe if your parents or whoever taught you math was from a country that wasn't the United States, sometimes they do that. I don't know which states exactly, or which countries exactly, but what traditionally we do in the US is we kind of almost think of this as like the barrier that we're trying to separate the like terms upon. So we want to move this 12x to the, this 12 to the other side. Now, because we're moving across the equal sign, we want this to disappear. So the only way I can make positive 12 disappear to make it nothing is to do the opposite, which is to subtract 12. That would make positive 12 minus 12, 0. And then I would just have an x on this side. I would bring the equal sign down. Now, the rule with equations, they have that word, almost the word equal in them, even though they don't have the L. So it's equal. You gotta do the same thing on the left that you did on the right. So if I chose to subtract 12 on the left to make this amount 0, I'm gonna have to subtract 12 over here on the right to make the equation equal, to make it still balanced. So now 7 minus 12 is actually gonna be -5. So that's what x is gonna equal. Over here, I've got one that has c minus 9 equals 13. So I want to move this constant to the right. So this is a -9. I have to do the opposite of -9, which is +9. That would make that turn into a 0. But if I do +9 on the left side of the equal, I got to do it on the right side because I got to make sure that they're equal. So that's c equals 13 plus 9, those are like terms, so I can combine them together, and you would get 22. Over here, I can see that I have 15 equals to -2r. Now, in this case, we don't actually have any like terms in this problem. We've got a -2r and a 15. But the idea is to isolate the r and get the r by itself is typically what we say, or I use the word sometimes isolate. So right here, you want to think about what operation is happening between the -2 and the letter r. And so because they didn't put a plus sign or a minus sign in between and they didn't use a division bar, we actually know that this is really 15 equals -2 times r. It's actually multiplication. When we have a whole number or an integer and a variable, we don't actually have to put a multiplication sign in between them. Because they're different, we know that multiplication is happening. So in order to do the opposite of -2, if we want to think about what would make this just r by itself, right? So when you think about the letter r, what number did I tell you was invisible in front of it? Right, there's really like an invisible 1 in front of the r. So what would I need to do using multiplication or division to turn -2 into the number 1? So when we're doing the opposite of addition and subtraction, we're trying to get addition and subtraction numbers to turn into zeros. So if it was adding 12, we're going to subtract 12 so it turns into a 0. But when we're trying to solve something that had multiplication involved, we want this to turn into the number 1. So we're actually going to use the identity property of multiplication, which is if you divide -2 by -2, remember when you learned in middle school that any number, when you divide it by itself, it actually gives you 1. So this -2 over -2 turns into the number 1. So that turns into 1r, which is what we wanted. But we do have to balance the equation, so over here we also have to divide by -2. So 15 divided by -2, in some cases you can just leave it like that. You can either write 15 over -2 as your answer. Typically we don't put the negative sign in the denominator. We might write it as -15 over 2. Might just move the negative up to the top. Or we might put it in line with the fraction bar. These are all the exact same number. Oh, sorry, the sun is coming into my house right now, and so I'm getting some shadows. So I've got 15 over -2, but in math, for some reason, we just don't put the negative in the denominator. Then we've got -15 over 2 or just -15 over 2. So these are all the same thing. Or we can actually divide it, which would give us -7.5. So we can write that as the answer. And then lastly, in this one, again, we've got an a divided by -3. So because when we have division or multiplication, we're trying to make this number turn into the number 1. So the opposite of dividing by -3 is actually, I'm sure you know, multiplying by -3. And this is really, if you want to think about it like you learned in middle school, also with fractions, you can think about it as -3 over 1 or just -3. So what usually happens is your teacher, at least I usually, really quick, just like cross out -3 and the -3 down here and kind of just say, oh, those cancel. But what's really happening is you're doing -3 times a. Remember, with multiplication with fractions, you multiply across. And then 1 times -3 is -3. And remember what we said over here, anytime you have the same number over itself, it's actually the number 1. So right here, -3 divided by -3 is actually the number 1, a. And then because I have to balance the equation, if I multiply this side by -3, I have to multiply this side by -3. Now I don't need to put it over 1 here because it's not a fraction, and I can just multiply that. So that's going to give me -12.6 for my final answer. All right, so that's that. I'll take you over so you can see my dogs, in case you stayed to the end of the video. So this is Tinkerbell, and then that's Mama. She's the one that was barking. That one there is Mama, and then that's Tinkerbell. And then this is Onyx over there. She was barking too a little bit, and those are my dogs. Anyway, I hope you guys have a great day.